So, let's go. The Milky Way looks empty. It isn't. Right now, things are moving through it. Invisible things, fast things, ancient things, and a few of them are closer than you think. Here are 6 of the creepiest. Number 1. The 100 million ghosts. Picture the Milky Way the way most people picture it. Stars, lots of stars, gas clouds, a few planets. Mostly empty space between everything, vast and quiet and harmless. Now add 100 million invisible things that you cannot see, cannot detect, and cannot predict. Things that drift silently through all of that space with no light coming off them, in any wavelength ever. Things whose only advertisement is what they do to the light of something else when they happen to drift in front of it. There are roughly 100 million rogue black holes drifting through the Milky Way right now. Not clustered somewhere safe and distant, not locked inside a dramatic nebula that you could point to on a map and say, okay, stay away from that area. Scattered. Everywhere, through the spiral arms, through the quiet suburban neighborhoods between stars, through the space between here and the nearest star system. One black hole for every 1 or 2 stars in the galaxy. We have confirmed exactly one of them. That's not a rounding error. 100 million drifting invisible stellar mass black holes, and the entire sum total of human observation has directly detected one. And even that one might not be a black hole. The team that found it, after years of Hubble observations, admitted the object could be a neutron star instead. They're not completely sure. The most precisely studied rogue compact object in the galaxy, and we still can't say with certainty what it is. Here's why this is so hard. A rogue black hole doesn't eat anything. When a black hole is part of a binary system with a companion star, it pulls material off that star, that material heats up, it glows in X-ray, and we can find it. Easy, relatively speaking. But a rogue black hole has no companion, nothing to eat, nothing falling in, no accretion disk, no glow, no signal. It just drifts through the galaxy in total silence, and the darkness around it looks identical to the darkness everywhere else. The only method we have is gravitational microlensing. You watch millions of background stars constantly, and you wait for a black hole to drift in front of one of them. When it does, it bends the light from that star, warps it into a brief, faint brightening. The event lasts days to weeks. Then it passes, and the black hole moves on. And you had better have been watching exactly the right star at exactly the right moment, because you won't get another chance. The black hole is gone. You don't know where it went. The nearest one is probably around 80 light years away. Probably. That number is a statistical estimate, not a direct measurement. We haven't seen it. We've just calculated that, given how many there probably are and how they probably distribute, there's likely one at roughly that distance. It could be closer. It might already be in the general neighborhood of stars you can name. And here's the scenario that gets strange to sit with. If a rogue black hole drifted through a solar system, through our solar system, the first sign would not be the black hole. You would never see the black hole. The first sign would be that things started going wrong. A planet's orbit would shift. Something massive was tugging at it from a direction that looked empty. Gravitational anomalies deepening, worlds destabilizing. A planet flung wide, orbit unraveling, sent spiraling outward into permanent interstellar darkness. And whatever was responsible for all of it would already be gone by the time anyone figured out what happened. Moving on, silent, to the next patch of space. 100 million of them, one confirmed. And that one might not even count. Number 2, Cannonballs from the center. The black hole at the center of the Milky Way is called Sagittarius A star, 4 million times the mass of the Sun. It's been sitting there for billions of years, and in that time, it's been doing something that sounds like something out of a myth. It's been firing stars. The mechanism is called the Hill's mechanism, and it works like this. Every so often, a pair of stars orbiting each other, a binary system, wanders too close to Sagittarius A star. The black hole's gravity grabs the pair and tears them apart. One star falls in, captured, gone. The other one gets catapulted. The gravitational energy from that disruption transfers into pure velocity, and the surviving star shoots outward at speeds that nothing in normal stellar life comes close to. Thousands of kilometers per second, fast enough to cross the entire galaxy and keep going, fast enough that the Milky Way's gravity can't hold it anymore. These are hypervelocity stars. Stars that are, right now, in the process of escaping the galaxy. The fastest one ever found is called S5-HVS1. It's moving at 1,700 kilometers per second. That's 6 million kilometers per hour, or roughly 3.5 million miles per hour. It could cross the distance from Earth to the moon in about 4 minutes. Our entire solar system moves through the galaxy at around 200 kilometers per second. This star is moving more than 8 times faster than that. Scientists traced its trajectory backward, calculating the precise path it's been on since it left. The ejection happened 4.8 million years ago. That's when our ancestors, early hominids just beginning to walk upright, nowhere near inventing anything, were alive in Africa. Sagittarius A star caught a binary pair, destroyed one star, and fired the other one across the galaxy at 6 million kilometers an hour. S5-HVS1 has been traveling ever since. It's currently about 29,000 light years from Earth. In roughly 100 million years, it will exit the Milky Way entirely and drift through intergalactic space until the universe ends. And the galactic center is not the only factory. In 2024, a group of citizen scientists, regular people running a sky survey project from their home computers called Backyard World's Planet 9, spotted something strange. A dim, cool, ancient star moving through the solar neighborhood at over 1 million miles per hour, fast enough to escape the galaxy. Scientists followed up with the Keck Observatory and traced it backward. It didn't come from the galactic center. It came from a globular cluster, one of those dense, ancient balls of hundreds of thousands of stars that orbit the Milky Way in the halo above and below the disk. Something in that cluster ejected it, possibly a collision between compact objects. Possibly a stellar mass black hole encounter inside the cluster core. The mechanism isn't fully understood, which means there are ejection factories scattered through the galaxy that we haven't fully mapped, producing hypervelocity runaways through processes we haven't pinned down yet. Then there are the white dwarf runaways, and these ones are genuinely strange looking. Sometimes 2 dead stars, 2 white dwarfs in a tight binary, trigger each other into catastrophic double detonation. One explodes. The blast wave hits the second, which also explodes. And the remnant, the surviving wreckage, gets kicked outward at hypervelocity. These runaway white dwarfs have been found moving at over 2 million miles per hour, but the part that makes them visually wrong is their chemistry. Almost every star in the Milky Way has an atmosphere made mostly of hydrogen and helium. That's just how stars work. These runaway white dwarfs have no hydrogen, no helium at all. They're made entirely of carbon and oxygen, the deep interior material of stars, stuff that normally never sees the surface. They look like nothing else in the galaxy. They came from events violent enough to turn stars inside out, and now they drift compositionally alien through a galaxy full of normal stars they no longer resemble. There's also the Cannonball pulsar, PSRJ 0002. A neutron star discovered by citizen scientists running a distributed computing project moving at roughly 2.5 million miles per hour, fast enough to eventually escape the Milky Way. What makes it especially eerie is that it left a trail. A narrow dart-like tail of radio emission streams behind it, pointing directly back at the expanding shell of debris from the supernova that created it, a remnant called CTB1. You can look at this object and see exactly where it came from and exactly where it's going, with total clarity. It's 53 light-years from its birthplace after only 10,000 years of travel. At that speed, it could get from Earth to the moon in 6 minutes flat. The galaxy has been doing this the whole time, quietly loading and firing. Stars launched when our ancestors were learning to walk, white dwarfs made of impossible chemistry, cannonball neutron stars with their own wake pointing back at the crime scene, and somewhere out there are hundreds more, still being found, still being traced backward to moments of violence we'll never witness directly. Number 3. The visitors. 3 times in 8 years, something from outside the solar system came in. The first time, October 2017, caught everyone off guard. An object came screaming in from interstellar space, swung around the sun, and headed back out. They named it Oumuamua, Hawaiian for something like distant messenger arriving first. It was shaped like a cigar, or maybe a flat pancake, tumbling as it moved, roughly 400 meters long, dark red, with a featureless surface that matched nothing in the catalog of known solar system objects. For a few weeks, Oumuamua was just an interesting anomaly, weird shape, unusual origin, moving on. And then the data came back and something didn't add up. As it left the solar system, Oumuamua sped up, not by a dramatic amount, but by more than gravity and sunlight alone could explain. It was accelerating, silently, with no visible cause, no gas trail, no dust cloud, no visible outgassing of any kind. It was just moving faster than it should have been, in a way that no known natural mechanism fully explained at the time. Some scientists proposed it might be a new class of object, something containing buried ice that releases invisible hydrogen gas when sunlit, providing thrust with no visible signature. Others proposed geometry so extreme, a structure as thin as a piece of paper relative to its width, that radiation pressure could explain the push. A very small number of scientists, including one from Harvard, suggested it might be technology. That framing got a lot of attention. The mainstream scientific conclusion is the hydrogen outgassing or a dark comet explanation. But Oumuamua remains the object that made careful, skeptical scientists stare at clean data for months and genuinely argue about what they were looking at. The second visitor, Borisov, arrived in 2019 and behaved more politely. An interstellar comet, icy, active, trailing gas and dust the way comets are supposed to, weird only in the sense that it came from another star system entirely, carrying chemistry from a place we'll never visit, passing through and gone. Compared to Oumuamua, it was almost reassuringly normal. Then came the third one, July 1st, 2025. A survey telescope in Chile spotted something incoming and reported it to the Minor Planet Center. Within hours, pre-discovery observations were found going back weeks. It had been there, unnoticed, in the archived data of 3 separate telescope systems. They named it 3I/Atlas. Its orbit has an eccentricity of 6.141. For context, a perfect circle is 0. Earth's orbit is 0.017. Oumuamua was 1.2, Borisov was 3.4, and 3I/Atlas was 6.141, so far beyond bound that its path through the solar system doesn't look like a curve. It looks nearly straight, a bullet passing through, indifferent to the sun's gravity, barely deflected. It came in at 68 kilometers per second at closest approach to the sun, the highest speed ever recorded for any solar system visitor. James Webb Space Telescope looked at the cloud of gas surrounding its nucleus and found carbon dioxide, water, carbon monoxide, carbon. Chemistry assembled somewhere else around a star we cannot identify, carried across light years and delivered briefly into our backyard. Scientists traced its trajectory backward through the galaxy, running tens of thousands of simulations, tracking where it could have come from and how long it's been traveling. Their best estimate, 3I/Atlas, originated from a stellar system around 9.6 billion years old. The Sun is 4.6 billion years old. The Earth is 4.5 billion years old. This comet was already 5 billion years into its existence before our planet formed. It has been moving through interstellar space for longer than Earth has existed. It flew past us for a few months in 2025. Then it was gone, heading out of the solar system forever, carrying the chemistry of someone else's ancient dead star system back into the dark. And here's the number that should change how comfortable you feel. Right now, inside the orbit of Neptune, there are an estimated 10,000 objects this size passing through our solar system from interstellar space. We can't see them. We don't have instruments sensitive enough, covering enough sky, watching continuously enough to catch them. They're in here right now. Interstellar visitors, anonymous and undetected, threading through the planets like the solar system has always been a public space. Because it has. It always has been. We just didn't know. The solar system is not sealed. Number 4, worlds without suns. Here's something nobody told you when you were learning about planets. A planet doesn't need a star. When solar systems form, the process is not orderly. Giant planets migrate inward, jostle each other, destabilize orbits. In dense young star clusters, other stars pass close and pull at planets from the outside. Some planets get bounced from star to star like cosmic hand-me-downs, captured briefly by one stellar gravity well and then flung away by the next. Astronomers at the Ulysses Research Center have called these objects ping-pong planets, and some don't get caught by anything at all. Some just fly free, ejected entirely, launched into the dark between the stars with no sun, no warmth, no orbit, just drifting forever. These are called rogue planets, free-floating worlds, and there may be more of them in the Milky Way than there are stars. In May 2024, astronomers confirmed one. A world roughly the mass of Saturn, drifting approximately 10,000 light-years away toward the galactic center. It's the first rogue planet ever with both its mass and its distance directly measured, not estimated, not inferred from incomplete data, but pinned down using simultaneous observations from Earth and a space telescope in orbit, triangulating the object's position like a pair of eyes, doing depth perception. It formed around a star. The star's system destabilized. The planet was thrown out. It has been alone since then, and it will be alone until the galaxy itself is unrecognizable. The surface of a rocky rogue planet, stripped from its star and left in the void, sits close to absolute zero. Around minus 270 degrees Celsius, just barely above the coldest temperature physics allows. No day, no night, no seasons. Because seasons require a star. Just permanent dark and permanent cold, and the occasional faint photon from a distant galaxy brushing your surface after traveling 1 billion years to get there and illuminate nothing. But then James Webb Space Telescope looked at the Orion Nebula and found something nobody expected: rogue planets traveling in pairs. 2 planets gravitationally bound to each other, orbiting a shared center of mass with no star anywhere near them. Binary rogue worlds. The image showed over 40 of these pairs. Nobody knows exactly how they ended up together. The leading theories involve chaotic ejection events where 2 planets happened to be flung in the same direction with similar velocities and captured each other gravitationally during the process. But that should be extremely rare. And there were 40 of them in one nebula. The math doesn't quite work yet, and the data is real. Now here's the detail that makes rogue planets genuinely complicated rather than just dead and cold. A rogue gas giant retains its internal heat for billions of years. And if that gas giant has a large moon, which is not a stretch, given that Jupiter alone has nearly 100 moons, then the gravity of the planet flexes the moon continuously as the moon orbits. That flexing generates heat. Tidal heating. Europa, one of Jupiter's moons, has a liquid ocean under its icy surface right now, not because it's warm near Jupiter, but because Jupiter's gravity is constantly squeezing and relaxing it. That process works without sunlight. It works in the dark. It works in the interstellar void, on a moon orbiting a rogue planet billions of light years from any star. The Roman Space Telescope and the European Space Agency's Euclid Observatory, working together, are expected to detect over 100 rogue planets in their first year of combined operations. Current estimates for the total number across the Milky Way run into the trillions. Trillions of worlds in the dark, most of them dead, some of them warm inside. A very small number of them, possibly, not entirely quiet. Number 5. The thing that reached across the galaxy and touched us. On December 27th, 2004, something happened on the far side of the Milky Way, and it changed the behavior of Earth's sky. The object is called SGR 1806-20. It sits about 50,000 light-years away in the constellation Sagittarius, behind the galactic center, on the opposite side of the Milky Way from here. It's a magnetar, a neutron star with a magnetic field so powerful that if you placed it where the moon is, it would be strong enough to pull the iron from your blood from that distance. The most intensely magnetized object ever directly observed in the universe. About 20 kilometers across, city-sized, a teaspoon of its material weighs approximately 1 billion tons. On that December day in 2004, the crust cracked. Magnetars build up strain the way tectonic plates do, except the force driving the strain isn't heat or pressure from below. It's magnetic. The field is so intense, so twisted and knotted, that it physically deforms the neutron star's surface. A solid crystalline crust, harder than any material that exists on Earth, warping under magnetic stress until something gives. When the crust fractures, the energy stored in the magnetic field releases. What comes out is a burst of gamma radiation moving at the speed of light in every direction, carrying more energy than most events in the observable universe. In 0.2 seconds, SGR 1806-20 released more energy than the sun emits in 250,000 years. The wave crossed 50,000 light years. It hit Earth. Satellites registered it simultaneously. The ionosphere, the layer of charged particles wrapping the upper atmosphere, the thing that makes global radio communication possible, briefly expanded and ionized more intensely than normal. From the other side of the galaxy, a cracking crust on a city-sized dead star changed the behavior of our planet's sky. Measurably. Detectably. The instruments weren't even pointed at it. The radiation came through the spacecraft from behind and still saturated the detectors. Astronomers had to piece together what happened after the fact because essentially every X-ray and gamma-ray instrument in orbit was overwhelmed. It was too bright for the things we built to look at bright things. If SGR 1806-20 had been within 10 light-years of Earth instead of 50,000, the ozone layer would have been stripped away. The surface of the planet would have been bathed in lethal radiation. This is not a dramatic extrapolation, it's a calculation, and multiple independent research groups have run it and gotten the same answer. Now sit with the timing. The crust cracked 42,000 years ago. That's when the light was generated. 42,000 years ago, Neanderthals and early Homo sapiens were both alive, both living in Europe, both looking up at the same sky from opposite sides of the continent. The Magnetar broke open while our species was still sharing the planet with another species of human. The gamma radiation has been traveling across the galaxy since then, and it arrived at Earth on December 27, 2004, and briefly pushed our ionosphere outward, and then it was gone. We felt an event from 42,000 years ago, from 50,000 light-years away, with an atmosphere that got nudged by it. The astronomer Victoria Caspi at McGill University, one of the world's leading magnetar researchers, put it simply, magnetars are the only deep space objects that directly affect Earth. There are 29 confirmed active magnetars in the Milky Way, 29 on the list, and magnetars are young. They lose their extreme magnetic field in about 10,000 years and become effectively invisible, indistinguishable from ordinary neutron stars. Which means there are millions of dead former magnetars drifting through the galaxy right now, quiet, ordinary looking, with nothing to show for what they used to be. 29 active ones that we know about. We have been watching the sky seriously for about 100 years. The galaxy is 13 billion years old. Number 6, the objects that don't follow the rules. This last one isn't a single dramatic object, it's a category, and the category might include up to 60% of everything orbiting near Earth right now. They're called dark comets. From the outside, they look like asteroids. They orbit the sun like asteroids. They have no glowing coma, no dust tail, no plume of gas catching the sunlight. Every piece of equipment you'd use to identify a comet looks at them and says, nothing. Just a rock on a normal-ish orbit doing what rocks do. Except they're not doing what rocks do. They're accelerating in ways that gravity and sunlight cannot explain, slightly faster than they should be moving, on trajectories that drift from the predicted path. And there is no visible source for the push. The first hint came from Oumuamua in 2017, which you already know, but then astronomers went back through the solar system catalog and started looking at other near-Earth objects more carefully. They found one. Then 7 more. By 2024, the confirmed count was 14, published by a team led by planetary scientist Darryl Seligman, who had been hunting this class of objects for years. The more carefully they looked, the more they found. And they all did the same thing, moved slightly wrong in a way that required something invisible pushing them. The leading explanation is water ice that's buried too deep to sublimate into a visible cloud when warmed by sunlight. When cosmic rays, high-energy particles streaming through the solar system, constantly hit that ice, they break the water molecules into their components. The hydrogen escapes, invisibly. No dust, no cloud. Just a tiny, silent exhaust of gas that provides a small but real thrust. No signature, no warning, no way to observe it directly with current instruments. The 2-sentence version of why this matters for the wrong reasons. Every impact prediction model ever built assumes that asteroids follow gravity. If up to 60% of near-Earth objects are dark comets, those models have a blind spot. A dark comet could be on a trajectory toward Earth, its orbit gradually adjusting via invisible outgassing, and the calculations saying it will miss might be built on an assumption that isn't true for this particular object. Planetary defense researchers are aware of this. It is not a comfortable thing to be aware of. And then there's the final strange loop. Oumuamua, the interstellar visitor, the object that started the entire modern debate about weird space things, the thing that launched 1,000 think pieces and at least one serious Harvard paper suggesting alien technology, was retroactively reclassified. It's now considered the founding member of the dark comet category. The first interstellar object ever detected was also simultaneously the first example of a whole new class of solar system object. It arrived from outside, behaved in ways that broke the existing models, and in doing so accidentally revealed that the same weirdness had been hiding in our own solar system the entire time, in objects we'd been cataloging for decades without noticing. The galaxy has 100 million invisible black holes. It has billions of worlds drifting in the dark. It fires stars out of its center at 6 million kilometers an hour, and they've been flying for millions of years before we notice them. It has a city-sized magnet 50,000 light-years away that tapped us on the shoulder in 2004, and we barely registered it. It sends objects from 9 billion-year-old dead star systems to visit our solar system for a few months and then disappear. And then, right here, in the neighborhood we've been mapping for centuries, there are rocks quietly cheating physics in ways we're still working out, moving wrong, in plain sight, outnumbering the ones that behave. We mapped the galaxy and called it empty. We were wrong about what empty means.